Okay, continuation. This is part 2. If you didn't look at part 1, go back, do part 1. So I'm in the middle of going through the FRQ from the course exam description. It's a number 1 style question, and we are on B. I mentioned positive control. Positive control is a group in the experiment where you do something and you are expecting to see your result. So in this case, the positive control is that they test on an experiment or test on a species or a strain of insects that does die from insecticide, right? They want to start with something that is not resistant, and they're looking at how resistance is affecting it over time as this strain changes. If we were looking for a negative control in this group, it would be to not test them with insecticide, right? It would be just like, let the mosquitoes do their thing and we should see them not dying. That tells us that our insecticide is working. We have a positive control working on that, a different group, right? So, and then down here, the last part of B, justify exposing some mosquitoes to the untreated filter paper each time. So this is, in a sense, an aspect of this experiment that is sort of acting as a negative control, but not explicitly. This answers, it's coming from the statement in the reading. A mosquito strain that is susceptible to the insecticide displays at least 95% mortality in all experiments. So here's a strain. If we treat it with insecticide and it is susceptible, we get about, or at least 95% of them dying. If we take those same susceptible mosquitoes, but we treat them with nothing, we only see about 10% die. So that confirms both ends of this experiment. A, that these mosquitoes are not dying for no good reason, right? Normally we would see 10% if we do nothing. And then if we positively treat them with this chemical, we do expect to see 95% of them dying if this is a susceptible strain to this insecticide. Okay, so this part in B is a little tricky. We didn't do a ton of this. I was mentioning in a transformation experiment, so when you have bacteria exposed to a plasmid or not, right? You're doing an experiment of giving them a plasmid, plating them with bacteria or antibiotic to make sure that it's like you're screening them out, right? But if I just take normal bacteria and grow them on a plate with no antibiotic and no plasmid, that's sort of my negative control of, like, I've done nothing to them. These bacteria should be alive, right? That kind of confirms that your bacteria are in fact viable. If I take those same bacteria, don't treat them with a plasmid, but I do put them on a plate with antibiotic, that's my treatment that I'm expecting it to kill them, okay? Kind of similar to these experiments. Taking a strain that should die from insecticide, treat them with insecticide, positive control, they should die. Why are we doing it with untreated filter paper? It's basically to make sure that they're not dying from other reasons, right? So we can go forward and study the insecticide use. So I think that's what I have at the bottom. You are called to identify how they made sure the insecticide worked and killed mosquitoes, and that when not exposed to insecticide, mosquitoes wouldn't die. That's what we're looking for in B. In C, I love this. So C is a describe, calculate. So these words aren't bold in the original prompt. I'm doing that in this PowerPoint. Don't forget that you have your FRQ task verbs. So if you go and link to this, that's the link it would take you, this course and exam description. It's a big fat binder I had in the classroom and what my posters were coming from. But in here, it's a big link. The FRQ that I'm going through is from here, right? Sample exam questions. But exam overview, this is where you also got, stand by, so it's going to waste my next 15 minutes, task verbs, right? You have this list of task verbs that I gave you on a cardstock. If you don't and you want to have this while you're doing your AP Bio test, like, you can have that. Like, what's the difference between describe and explain, right? And identify. So it's subtle, but I think explain tends to have the most you would have to put into an answer, where describe is like, regurgitate content, identify is pulling something out of the data that is presented, okay? Explain is sort of like a combination of the two, I think. explain how, require, yeah, a little bit more analyzing relationships. So where was I? So, based on data in Figure 2, describe whether mosquitoes from region A, where we treat with a lot of insecticide, or from region B, where we don't. So, describe whether mosquitoes from A or B are more likely to exhibit greater evolutionary fitness if exposed to this insecticide in their native environment over the time period given in the experiment. So, describe, is it region A or B that is surviving better when exposed to it's the type of insecticide. There was a D1 and a P1, okay? So who has less mortality with that chemical? So who has better evolutionary fitness? Are they the ones in region A or region B? So go to the chart here and you're looking for this section. Like, I'm not looking at the delamethyl whatever. I'm looking at the one with paramethylin, okay? So it's the insecticide that contains a kind of chemical that is supposed to kill mosquitoes. Where are they showing better evolutionary fitness? Lots of mortality here in region B because they're not used to the insecticide. We don't normally treat there. Here in region A, where we are often treating with large amounts, we are seeing less death of mosquitoes. Okay, so it's in region A. I feel like that's a Bozeman kind of statement. What did I see? Mosquitoes from region A are much more likely to survive, to reproduce, so region A mosquitoes have greater evolutionary fitness, bottom left of the graph. Remember that evolution content is not on this year's exam. This just was a good question otherwise, but this is a little bit of evolution here. So the next one, describe any significant change in the susceptibility of mosquitoes from region B to each of the two insecticides over the 2-year period. So we're describing significant change. When you see the word significant or statistically significant, these are when you're looking at error bars and things like that. So significant change, what are they likely to die? We're looking at region B of the 2 insecticides over the 2-year period. So let's go back to the graph, use this one where it's a little bit bigger. So region B, I'm just looking at this side of the graph. And remember, time-wise, it's going from back in time up to more current time. So with the D insecticide, there's some significant differences here. Like the bar, you don't see the bottom of the bar, which is a little strange to represent that. This one might overlap with that one. So small changes. But then in June 2010, we do see a significant drop in region B with mortality to delta. I'll call it delta. And so these I would call significant differences. To the P version, these 3 changes, the 2008 and 2009s, I would call these insignificant changes. And then suddenly out of nowhere, June 2010, we do see a significant drop in mortality. So you just need to describe that in C. The rubric has all of this. Can I make that? Oh, too far. Boop. So they have it describing any significant changes in percent mortality or susceptibility, right? So who's dying or who's susceptible to die of the 2. So you do have to describe both of them. This is a 1-pointer part of this question, so I don't know how it would be scored if you describe one and not the other. I don't think they give half points. I think you have to have both. And so here is like how one could describe those. Okay. And the last part is still in the next one. For C, use table 1, calculate the frequency. Ooh, I want to underline that word. Frequency. No, not all the words. Frequency. Of the allele coding for phenylalanine in each population of mosquitoes. Round your answer to 2 decimal places. So, love this. Okay, made this very small. Oh wait, no. C. Where was I? C. Here we go. So if we're going to be calculating frequency, this is again related to evolution. Probably will not come up. There might be a touch of it with maybe some heredity pieces. But we are looking at allele counts. And if it's frequency, we're looking at a decimal. So a 0 point something something answer. And we're looking for phenylalanine. So Actually, I want to copy this. I'll put this over here. Okay. So we have, I can go higher. Here we go. So remember that and we're looking at both regions. So both regions for phenylalanine. So we're going to be looking at these numbers, keeping in mind the A's and the B's we should be doing separately. So for region A, heterozygotes, and we asked for a certain time, coding it in October 2008. So we're only looking at the top row. So here's this number 5. We have 5 heterozygotes in region A, so they are contributing 5 phenylalanine alleles. They would also have 5 leucines, but we're not counting those. And then there are 31 of them that are homozygous, coming in with 2 alleles for phenylalanine. That's why it's doubled here, 2 times 31. So it's a total of 67 phenylalanine alleles, and total mosquitoes tested, 39. Double that is 78 alleles, right? So keep that in mind. These are individuals, but what we're calculating is alleles, so each person brings in 2 alleles to the bucket. So it's 0.85 frequency or 85%, but they're looking for frequency. The B region, calculating that in 2018, we got a total of 27 individuals. Double it, it'll be 54 total alleles. 5 of them individuals are coming in with 1 copy of phenylalanine, and 2 of them are coming in with 2 copies. So we're going to add the 5 plus a doubled 2, we get 9. 9 out of everybody is 16 frequency, 0.16. Okay. I can make this smaller and leave it on here. Okay. That was the rest of B. Wow, this is taking forever. It's okay. All right, C, based on, oh no, that was the rest of C. Cool. D. D's a long one. So in D's, for question style 1, they're actually like making and justifying predictions. You're kind of going beyond what the experiment has already talked about, and you're kind of doing something else. You might, in this one, it looks like we are asked to predict, and then I do another one where we provide evidence for the scientist. So, using mosquitoes from insecticide-free areas, the scientists developed mosquito strains with amino acid substitutions at other positions in the sodium channel protein. They exposed the mosquito strains to non-pyrethroid insecticides, so some other chemical. Predict the susceptibility of the mosquitoes to these new non-pyrethroid insecticides. So first of all, reword those 2 statements. When you get a question that has a lot of new info coming at you, you should like treat it again like a new prompt, like what am I getting out of this? So insecticide-free areas mean usually there's initially no resistance, right? If an insecticide is brought in where it's not usually been before, it's probably going to kill mosquitoes because there's no reason to have selection in favor of surviving. So strains with other amino acid mutations. So they've got more mutants. Other parts of the protein maybe are involved with resistance or susceptibility to something else. So non-pyrethroid insecticide. The pyrethroid is the mosquitoes, what they're developing a resistance to. So is there some other chemical that we can get to kill the mosquitoes? Okay. So predict the susceptibility of mosquitoes to the insecticides, these new non-pyrethroid insecticides, like they should die. Right? That's what they said. The mosquitoes will all die, or the mosquitoes will be 100% susceptible. Those are good enough answers. I kind of like thought into this one a little more. New strains would be killed by this new insecticide since it is something that they've not been exposed to, and as long as it acts on blocking that sodium protein or functions in some other way of killing them. So the last part, 45 seconds, probably not going to make it. Using mosquitoes. So the last part, the scientists claim that you know what, I have like 40 seconds, I'll stop here, come back, part 3, okay? I'm going on, this is over half an hour talking about this question. You will technically have about 25 minutes to do a question like this, and then upload your work for 5 minutes. So they stated very clearly, like, don't expect to finish a question, right? Work for 25 minutes, stop working, upload your work in the last, like, uploading time. So don't worry about this. This is a doozy one, okay? I'll see you in part 3.